This is section 4.1, and we're going to get our definition of a determinant for an n by n matrix. So square matrix. And so we start with the definition of a minor. So this is a minor. And we will let whoops, that's not an I. Mij of a matrix A. Or we can leave off the A if we know what matrix we're talking about. Denote the determinant of the n minus 1 by n minus 1 submatrix of A, okay, formed by deleting the ith row and jth column of A. Okay, so it's a determinant and of a smaller matrix than A. Okay, so and this is Mij is the ij, let me write that again, is the ij minor of A. Okay, so now just as a quick example, we'll use a 3 by 3 because we only know how to do 2 by 2 determinants. So anything bigger, we have to wait on our definition of the determinant. But if I have something like A is equal to the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, then something like M, if I go with 1, 1, then that is equal to the determinant. Well, let me use our straight line notation. That's the determinant of, now I have to get rid of that row and that column, so I'm just left with the 5, 6, 8, and 9. And so that's equal to 45 minus 48, which is negative 3. Okay, similarly, I could talk about M, say 2, 3. Well, that's the determinant of, I don't want row 2 and I don't want column 3, so that leaves me with 1, 2, 7, 8. And so that is 8 minus 14, which is negative 6. Okay, so that's a minor. Okay, we just get rid of the row and column mentioned here. Oh, we've got here a kind of a confused face. Hopefully you all don't have that. It is just then that determinant. Okay. And so now here's our recursive definition of the determinant of A for any n by n matrix. And we say that the determinant of A is equal to A11 times the minor M11. And I'm not going to bother putting the of A, uppercase A in there. And then minus A12 M12. And then plus, and we'll go alternating plus and minus. And then it's at the end, we finally get here. And now here we need to toss in a -1 to the 1 plus n. And that's M1n. Okay, so that's a determinant. Now, we had to do that -1 to the 1 plus n because, you know, for instance, if n is 3, right? N is 3, we would have had 3 of these things. So the first one was plus, the second one was minus. The third one needs to be plus. And so if n is 3 and then plus 1 is 4, -1 to the 4th is positive. Oh, and I left off my A here, so let's try that again. A1n times M1n. There we go. Okay, and that is our recursive definition. We can do that with a summation formula. We say the sum j equals 1 to n, because that's what's changing is the j, A1, A12, A1n, the j part's changing. And so this is -1 to the 1 plus j times aij, sorry, not aij, a1j, and then times that minor m1j. Okay, so that is our determinant. And so if I want to do a 4 by 4, let's look at something that's 4 by 4. So A is equal to, and let's go, we'll do a, how about 4 by 4, let's start at like -8 or something. -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so if I have that matrix and I want its determinant, then this definition says I need -8 times the determinant of -3, -2, -1, 1, 2, 3, 5, 6, 7. And then I need a +7, because I want minus a -7, and times the determinant of -4, -2, -1, 0, 1, 0, 2, 3, and 4, 6, 7. Then I need a -6, so I'll go down here, -6 times the determinant of -4, -3, -1, 0, 1, 3, 4, 5, 7. And then finally, it was a -5, so now it's a +5. And I need -4, -3, -2, 0, 1, 2, 4, 5, 6. Yuck, right? So then that is equal to the negative 8 times, and I'm just going to work with the negative 8 here and write, okay, so now that's negative 3 times the determinant of 2, 3, 6, 7, plus 2 times the determinant of 1, 3, 5, 7, and minus 1 times the determinant of 1, 2, 5, 6, and then plus 7 dot dot dot. Wow, right? This is just plain ugly, and this is why we like technology, but we are also going to like a lot of theorems, because even technology would not like computing a determinant this way. But that's the idea. That is the definition, and how we would calculate one by hand. You know, so I would much rather have up here in this top row, if I'm using the definition, I would like a lot of ones and zeros. And then for the other ones, I would love ones and zeros and negative ones and so forth, because it'd just be way easier to do the calculations. But so you see, you know, we got this far. I got bored. I'm tired. I don't want to keep going. And yet we've got, this is only 1/4 of the whole thing. So it is a nasty, nasty process to use this definition. All right, so there is the definition and some examples of a determinant for an n by n matrix.